Let's start our practicals of the course Plant Physiology. Our first experiment is on the preparation of solutions. Solutions are systems in which one component is dispersed throughout the other in the form of molecules or ions. The dispersed substance is called solute and the dispersion medium is called solvent. The concentration of the solution is generally expressed in terms of percentage, ppm, molality or normality. There are several ways to express the amount of solute in a solution in a quantitative manner. The concentration of a solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. A concentrated solution is one that has a relatively large amount of dissolved solute, whereas a dilute solution is one that has a relatively small amount of dissolved solute. However, these terms are vague and we need to be able to express the concentration with numbers. One way to describe the concentration of a solution is by percent of a solute in the solvent. The percent can further be determined in one of the two ways, that is mass percent, which is the ratio of the mass of the solute divided by the mass of the solution, and by volume percent, which is the ratio of the volume of the solute and the volume of the solution. Mass percent. When the solute in a solution is a solid, a convenient way to express the concentration is a mass percent, which is a gram of solute per 100 gram of solution. Mass percent can be determined by the formula percent by mass is equal to mass of solute divided by mass of solution into 100. Suppose a solution is prepared by dissolving 25 gram of sugar into 100 gram of water. The percent by mass can be calculated by dividing 25 by 125, that is mass of solute divided by mass of solution, that gives 20%. That is, the mass percent of 25 gram of sugar in 100 gram of water is 20%. Sometimes you may want to make up a particular mass of a solution of a given percent by mass and need to calculate what mass of the solvent to use. For example, you need to make 3000 gram of a 5% solution of sodium chloride. It can be calculated by the formula the mass of the solute is equal to the percent by mass multiplied by mass of the solution divided by 100. That is 5 divided by 100 into 3000 gram, that gives 150 gram of NaCl. You need to weigh out 150 gram of NaCl and add to 2850 grams of water. Notice that it was necessary to subtract the mass of NaCl, that is 150 gram, from the mass of the solution, that is 3000 gram, to calculate the mass of water that need to be added. Next, volume percent. The percent of solute in a solution can more be easily determined by volume when solute and solvent are both liquids. The volume of the solute divided by volume of solution expressed as a percent yields a percent by volume of solution. If a solution is made by adding 40 ml of ethanol to 200 ml of water, the percent by volume of ethanol can be determined by dividing 40 ml of ethanol with 240 ml of solution, that gives 16.7% ethanol. So volume percent of 40 ml of ethanol in 200 ml of water is 16.7%. Next, ppm or parts per million. ppm is used to denote a very low concentration of a solution. It is defined as the mass ratio of gram of solute to 1 million gram of solution. 1000 ppm means 1 gram in 1000 ml of solution, whereas 1 ppm is 1000th of a gram, that is 0.001 gram in 1000 ml of solution. We know 1000th of a gram is equal to 1 milligram, and also 1000 milligram is equal to 1 liter. In that way, 1 ppm can be expressed as 1 milligram per liter. ppm is derived from the fact that the density of the water is taken as 1 kilogram per liter, that is equal to 10 to the power of 6 milligram per liter. 1 milligram per liter is 1 milligram divided by 10 to the power of 6 milligram, which is equal to 1 part in 1 million. Let's see how can we convert a ppm solution to percent. The part P in percent is equal to part P in ppm divided by 10,000. Let's see an example. How many percent are there in 5 ppm? It can be calculated by dividing 5 ppm with 10,000, which gives 0.0005%. So, 5 ppm is equal to 0.0005%. A percent solution can be converted to ppm by multiplying it with 10,000. A 0.003% solution can be expressed in ppm by multiplying it with 10,000, which gives 30 ppm. Concentration in gram per liter can be converted to ppm by multiplying it with 1000. A 5 gram per liter of solution, when it multiplied with 1000, gives 5000 ppm of solution. Another method of expressing the concentration is molarity. It is defined as the number of moles of solute dissolved in 1 liter of solution. 1 molar solution means 1 mole solute dissolved in 1 liter of solution, whereas 2 molar solution means 2 moles of solute dissolved in 1 liter of solution. Molarity N can be expressed by the formula N by V. N is the number of moles of solute, whereas V is the volume of solution in liter. The number of moles of solute is a ratio of the weight of the solute and the molecular weight. Let's see an example of finding molarity from number of moles and volume of solution. So the question is, what is the molarity of a solution if 1.47 moles of sugar is dissolved into 2.31 liter of solution? The molarity can find out the formula number of moles divided by volume of solution in liters. So 1.47 moles of sugar divided by 2.31 liters of solution gives 0.636 moles per liter. This is another example of calculating the molarity of a solution when 4 gram of NaOH dissolved in 1 liter of solution. N, the number of moles, is equal to weight of the solute divided by molecular weight. So N is equal to 4 divided by 40, the molecular weight, that gives 0.1 number of moles, and V, that is 1 liter, and so the molarity is 0.1 molar. This is another example of molarity. The question is, how many grams of NaCl will be needed to make 1.5 liters of an aqueous 0.5 molar solution? The equation for the molarity must be rearranged to solve for the moles of the solute. The moles of solute can then be converted into grams. As we know, the moles of solute is equal to the molarity multiplied by the volume of solution. That gives 0.75 moles. Now convert the moles of solute into grams by using the molar mass of NaCl. The molar mass of NaCl is 58.44, and so the grams of NaCl is 43.8 grams. So 43.8 grams of NaCl needed to make 1.5 liters of an aqueous 0.5 molar solution. Another way of expressing the concentration solution is normality. Normality is the number of gram equivalent of solute present in 1 liter of solution. It means the number of gram equivalents of solute divided by volume of solution in liter. The number of gram equivalents can be calculated by the formula the number of gram equivalents is equal to weight of the salt divided by equivalent weight. Normality is represented by the capital letter N. So the formula capital N is equal to capital V divided by EV in liter. W is the weight of the solute in grams, and E is the equivalent weight, and V, that represents the volume of solution in liter. And the unit of normality N is gram equivalent per liter. How can we calculate the equivalent weight? Equivalent weight of acid is calculated by dividing the molecular weight of acid with the basicity of the acid. Before calculating the equivalent weight of acid, it is necessary to know the basicity of the acid. The number of replaceable hydrogen atoms present in acid is equal to the basicity of the acid. For example, in the case of hydrogen chloride, its basicity is 1. There is one replaceable hydrogen atom in hydrogen chloride. In the case of sulfuric acid, the basicity is 2, and in the case of orthophosphoric acid, it is 3. Now we calculate the equivalent weight of hydrogen chloride. The equivalent weight is molecular weight divided by basicity. So equivalent weight of hydrogen chloride is 36.5, and in the case of sulfuric acid is 49. Now, what is a normal solution? What do you mean by a normal solution? When 1 gram equivalent of solute is present in 1 liter of solution, then that solution is a normal solution. What do you mean by n by 10 solution? When 1 by 10 gram of equivalent of solute present in 1 liter of solution, it is a decinormal solution. And what is a normal centinormal solution? It is 1 by 100 gram equivalent of solute present in 1 liter of solution. Whereas millinormal solution is when 1 by 1000 gram of equivalent of solute present in 1 liter of solution. Different normal solutions can be prepared by the formula N1V1 is equal to N2V2. N1 is the initial normality and V1 is the initial volume, and N2 is the normality of the final solution and V2 is the final volume. How can we prepare a 1 normal sulfuric acid? Concentrated sulfuric acid has a strength of approximately 96 to 98%. In case of 98%, that means 980 milliliters of sulfuric acid per 1000 ml of content acid solution. Generally, concentrated sulfuric acid in lab is of a strength of 98%. So let's see the calculation. First step is calculate the weight of sulfuric acid in 980 ml of sulfuric acid by multiplying it with its specific gravity of 98% sulfuric acid, that is 1.84. 980 multiplied by 1.84 gives 1803.2 grams. It means 980 ml of sulfuric acid in 1 liter of solution is equal to 1803.2 grams. Step 2. Calculate the number of moles in 1803.2 grams of sulfuric acid. As we know the formula, the number of moles is equal to given weight divided by molecular weight. That gives 18.4 moles. It means 1 liter of concentrated sulfuric acid having strength of 98% has weight of 18.4 and it has 18.4 moles. It means the molarity of 98% of sulfuric acid equal to 18.4 molar. It is equal to number of moles present in 1 liter of solution, which is 18.4 molar. Normality of sulfuric acid is twice of molarity. If molarity of any sulfuric acid solution we are taking, its normality will be the double of its molarity. Suppose we have 1 molar solution of sulfuric acid, then its normality will be 2 normal. Normality of 98% of sulfuric acid is 18.4 multiplied by 2, that is 36.8 normal. Molecular weight of sulfuric acid is 98 grams. Number of replaceable ions is equal to 2. So the gram equivalent weight is molecular weight divided by number of replaceable ions, that is equal to 49 grams. And the molecular weight is 2 into gram equivalent weight. Step 3. Prepare 1 normal sulfuric acid by using normality equation. That is N1V1 is equal to N2V2. As we know, the N1 is 36.8 normal. That is V1 can be calculated as 27.2 milliliters approximately. So to prepare 1000 ml of 1 normal sulfuric acid from concentrated sulfuric acid, only 27.2 ml of concentrated acid is diluted up to 1000 ml of water. Molality or molal solution. It is another way of expressing the concentration of the solution. It is the amount of the substance dissolved in a certain mass of solvent. Molality is defined as the number of moles of a solute per kilogram of solvent. Let's see the difference between molarity and molality. The difference lies in the number of moles that are present in the solution and a solvent. Molarity, which is a ratio of moles of a solute to total liters of a solution. So solution that includes solute and the solvent. Whereas molality, which is a ratio of moles of a solute to kilogram of solvent. Let's determine the molality of a solution prepared by dissolving 28.6 gram of glucose into 250 gram of water. We have the mass of solute, that is 28.6 grams, and we have mass of solvent, that is 250 grams, which is equal to 0.25 kilogram when expressed in kilogram. And the molar mass of glucose is 180.18 grams per mole. So we need to find out the molality. For that, we have to convert the grams of glucose to moles and divide by the mass of the water in kilogram. In that way, it gives 0.6235 molar glucose. So, when 28.6 gram of glucose dissolved in 250 gram of water, it gives 0.6235 molar glucose solution.